are saying the port 80 and 1236 which are required for AV are open. That's what they have done for. Whatever they say, they say they have opened it. They say that they are not closed. Okay. Yeah. Let us get back to session. Two announcements. First thing is I am not actually available on Friday. Friday I am actually giving a talk. So I will not take studies class on Friday. I think coordinator for the session will announce it. Someone from the Kannada class or some rescheduling later. Okay. Last Friday also I missed the class. I think I've already announced that, but I don't know what I did.
It's a test one.
They also cited a for the database course certification. So anyway, that's the reason why last Friday and this Friday again I am supposed to give a talk in one conference, so I will not be able to take those okay. Right. So last class I think we are looking at the functional dependencies and relations. I think what we have done in the last year and what are the functional dependencies and relationship. They're still there on my board. I'm looking at the chat box. If you are able to see the board, okay, I will sort of use this board. So, whatever I've written last time, okay, just seriously putting this laptop very close to the board. We are able to see the board. Are you able to see the board? What is on the board? Please put in the chat box if you are able to see the board. Otherwise, I'll adjust. There are two terms. Even half of the other now, if they agree on the value of A, they also agree on the value of B. So, what functional dependencies says is, if two tuples agree on the value of A, on the value of attribute A, they also agree on normally what a functional dependency means. Okay? A functionally determines B if there are two tuples in this relationship, student relationship or any relationship R A B, if the tuples T1 and T2, if you take any two tuples T1 and T2, if they agree on the value of whole number, they have to agree on the value of the attribute A. Okay? So you can't have two tuples which agree on the attribute whole number but not agree on the name. That's what we mean by that functional dependency. Okay? Where do functional dependencies come? These functional dependencies come from the domain. Okay? We take another instance of a relationship and will examine what are the kinds of functional dependencies that the relationship. Okay? I will take slightly a bigger relationship here to examine this. Okay? Let us take the case where I have house property, for example, let us say this is a relationship determining the house property. Okay, right? The house property, let us say, is uniquely determined by what is called the property number. Okay, you give a unique number to the property. Okay, you also give. Now let us say you also identify the city where this property is located. That's already okay. Property is all the attributes that are called property number, which uniquely identifies the property. Okay, for example, the house or the site where whatever the property is uniquely identified with a number across all the cities. Then you have the city, and within the city, there is a house number, okay, to this property. Okay. Then you can also have an area. I'm just seeing that they are able to see. Then the other attribute can be area. Okay. Then it can be price. Okay. And then it can be tax. These are the 5 attributes of this relationship called property. Okay. So, okay. Right. So there is a property relationship. There is a property number which uniquely identifies the property. The city in which the property is located. The house number within the city which uniquely identifies the property, then the area of the property, the price of the property, and the tax of the property. Okay, how much tax you are going to charge, or what is the tax that you will collect this property. Okay. This is the relationship. Now, if you want to examine what are the functional dependencies, okay. Am I audible? Is everything coming properly? Just seeing everything looks like connected. There's no problem to nurture. Right. Ramakrishna, if you are following, and then if you feel that there is any disconnectivity, please call me. Okay, my number. Before it is too late, and I just keep talking with them. Okay. Yeah. Okay. Okay. So, given this, now let us understand what are the dependencies, functional dependencies that can be there in this relationship. Okay. Now, if we assume property number is unique, okay, this becomes a candidate. One of the candidates is actually the property number, assuming that no property will have the same property number. For example, if you are giving couples for this year, let us say property number is going to be a integer, okay, and instance of this couple E is going to be property number, which is going to be now, let us say some 8, 5, 6, 2, 9, 1, okay. So 6 is a unique number, let us say we give, like the other part A for the property, let us say this is located in the city of Chennai. Okay. This is located in the city of right. Okay. And let us say this is the house number. Is 305 meters or something like that. The price is, let us say, some 10,000. Tax is, let us say, okay. This is one instance of this couple, this property couple. So there can be another instance of this couple. There can be multiple instances. For example, if there are there could be millions of these records. suddenly it is going to be 6-digit unique number. So this is suddenly going to be about a million records. And the another tuple with, let's say 92820, located in Delhi. Okay. And then it's let us say house number Delhi is 10. Okay. And then let us say the area is 200. Okay. And then the price is something like this. And the tax is, let's say, okay. So this is the other tuple. So, these are the tuples which are instances of this property. Now, we want to find out the functional dependencies that hold down this relationship. Okay? What is a functional dependency? Functional dependency means that does an attribute, one of the attributes in this or a set of attributes in this relation can determine the values of the other attributes. Okay? If so, then we call that as functional dependency. Okay? Now, these functional dependencies come from the domain. Okay? Knowing the domain, since we are assuming that property number is going to be unique, we will never get repeated in this relationship. So, this becomes the key attribute. This is an attribute which will uniquely determine each of these records. So, if you have this, it uniquely identifies. This will never be value will never be. So this is a unique attribute, unique value. Okay. It's also called the key attribute. Okay. Right. Now, in addition, if you say given the property number, okay, if four records, if there are four records, okay, in this, two records are there, if there is a key attribute, okay. And there is another record which the property number is exactly the same, okay, which means that there is another record with another instance of it, where it is also 8.2691. Then what we can be sure is these two records have to be the same. They have to agree on all other values of all other attributes. Which means that you can't have this if they agree on this attribute, if they agree on this attribute, they have to agree on the attribute of the city. Okay? They have to agree on the attribute of the house number. They have to agree. Okay? Have to agree. Once the property number they agree on, all other values of all other attributes have to be the same. We know this from the domain. Once you say that the property number identifies all other attributes. Okay? Right? So what we say now is property number functionally determines. Okay? This determines. Okay? City. This is everything. Functional dependency. A property number functionally determines the value of city. Property number functionally determines the value of house number. Functionally determines area. And combine all of the 150. Price. It functionally determines tax. Okay. Right? This is one FD or the number of FD. We can combine this to one single FD, where you can write property number, determine city, house number, area, price, and cash. You can also write it as property number determines city and one FD, property number determines house number and another FD, property number determines area and another FD. So you can write all those FDs separately as well. You can combine the FDs and put it as one single FD, and then all the right things can be combined and made into a single FD, because this property number uniquely determines tell you where the FTs keep coming from, where the functional dependencies come from. Now we take city plus house number also, let us say, in a given city, the house number is going to be unique. Okay? Given a city Chennai, let us say that the house number, again, whatever we give as a house number for the property. Okay? Even in a city, the house number is going to be only one. Given that, everything else can be identified. Okay? All other things are going to be put together. We are not going to have another property which has the same city and the same house number, which means that two properties, two houses in a city cannot have the same number. So you are not going to find the city same and the house number same for different houses. If they agree, city and the house number are same, then it means that they have to agree, okay, on all other values. Okay, on all other values. So what does that mean? There is another candidate key for this relationship. Okay? What does this mean? It means that there is another candidate key for this, because this is going to be unique. There is another candidate key, city, house number, in this relationship. Together, this is going to be unique. Okay? This is not going to be repeated. Okay? Now, given this, we can say city, house number, now property number. Okay? Given these two, they functionally determine the property number. If two tuples agree on city and house number, they have to agree on the property number. Not only the property number, they also have to agree on the area, price, and cash. It means that city and house functionally determines all these other attribute values. Okay? Right, property number, area, price, and tax. So we have now we have identified previously, let us say, all this as FT2. We have identified FT1 already. FT1 is property number uniquely identifies city, house number, price, tax, and this is FT1, functional dependency 1. This is functional dependency 2. Let us say, given an area, irrespective of the city we are in, okay, the price is also fixed. For example, a 100 square meter per square meter, the price of the property is fixed irrespective of the city. Whether it is Chennai, whether it is Delhi, whether it is Mumbai, Calcutta, let us say that the price is based on the area, which means that now we have another functional dependency FT, which says that area functionally depends. Okay. It becomes functional dependency across these attributes. Okay? Right? Area determines the price. Okay? Right? Now, we can also have more functional dependency here. Okay? Which can be saying that given a city, I determine the tax. For example, Chennai will have one tax. Delhi will have another tax. Okay. Mumbai will have another tax. So every city will have its tax. We will say that. It's possible. And if that is the case, we can say city functionally determines the tax. These are the possibly the four FTs domain. And I have the attribute property number, city, house number, area, price, and tax. Okay. Now, these candidate things are also coming from the domain, because I know property number I am not going to repeat. For two properties, I am not going to use the same name. That's how I know this is the key. In this relationship, this is the key. This is uniquely identical. Similarly, I know given a city, the house number is not going to be repeated. So city plus house number again can uniquely identify the property. So again, that's how the candidate is coming from the domain. Okay. Given this domain, given this candidate is, I know city and house functionally will determine the property number, area, price, and tax. I also know property number determines the city, house number, price, tax, and area. I also have additional dependency, which is given an area, I can calculate the price. Given the city, I can use the tax. Okay. Is that clear now? Okay. This is what we mean by functional dependencies. Okay. Functionally, one attribute depends on the other attribute. Okay. Right. So if one attribute determines functionally the other attribute, there are two couples. We agree on one attribute, we agree on the other attribute. Okay. If there are any questions, please put it on the chat box. I will be happy to answer. Okay. System is, okay. The practical system possibly could be different. They might use both city and the area to determine the price. Okay. Right? And not necessarily just the area to price without dependency to the city. Okay. But I am assuming in this case, area irrespective of the example, it is not logical to assume. Okay. The prices, the house prices in Chennai will be the same as house prices in Delhi. Okay. Delhi house prices suddenly may be much higher than Chennai house prices. Okay. And then, what I am capturing as data in my system, I am assuming that is irrespective of the, for example, the income tax purposes, they may actually, I don't know what they do, but they assume that given an area, given a city, for example, this is for HRA purpose or something, a house like a area. Then they will only go by all class city. We have the same area to price. Okay. Maybe similarly, the city to tax. So these are the functional dependencies that hold my relation. Okay, right? Is that clear? If you want to say that AQ Vijayanagar campus, did I answer your question? If you want to change it, you can. For example, you can say that no, this is not a functional dependency that holds me. It is city and area to price. Okay, you have to determine what are the functional dependencies that hold for this relation, given that you know the domain. Based on the domain only, you have to arrive at this functional dependency. Okay, right? Okay. Yeah, any other question? If no questions, this is very important. See, basically, the whole concept of relational database model design is dependent on understanding this relation and what are the functional dependencies that hold your relation. Okay, right? Why it becomes very, very important. For example, now look at okay, this is the part that I have. Okay, I'll be wiping this off. So if you have, because I have a limited code availability, so it would be nice if I actually be able to hold all this by mistake. Now I have to wipe off. So come up with. Okay. us understand what are the problems in this relationship because of these functional dependencies. Okay? And what would have been a better way of looking at this relation than the way I actually look at it. Okay? Right? First I will give the inclusivity, then I will try to get to the formalisms underneath this relational order. Okay? First understand intuitively what this whole thing is about. Okay? Right? Now let us say I capture all my data using, okay, this is the table for me, the relational data table. So basically, this is how I am going to capture the property data into my system. Okay? My property data will have the following attributes. The values of each one of these attributes will be captured as rows into my table. Okay? Now, I have some 3, 0, 1, 0, and 9. Okay? The constraints that I have, I know certain things. 3, 0, 3. Area is some 500 square meters. These are all artificial numbers. This is quantum. Like this, there are going to be so many other numbers. Okay? 8 to 3, 8 from 9. This is a E. Okay? This is how my data is going to be 4, 0, 4, 600. Okay? And then some numbers I'm giving. Okay? Like this, E1 another number. Up to some E1 some 1 here. Okay? Of number. So this is the all the tuples are there. Right? Okay? So the physical. Okay? Now imagine, okay, I hope you're all with me. Okay? Problem of teaching a class remotely is that I don't know how many students are. I can't see anybody's face except myself. Okay, yes. There's no. Since the classroom is non-existent, I don't know what I'm teaching. How many things will follow. Okay. Suddenly use the chat box to see the question. Okay. Now we said one of the I only talk about one functional dependency of identified. Okay, and then see why this is important for us. When we have captured data like this, what is likely to get an intuitive feel for us. What we are saying now, there is a functional dependency between city and cat. Okay. What does this mean? Given a city Chennai, the cat is dependent on that. Given a city here, for example, there is another property located in Chennai somewhere, then there is a cat there. That cat has to agree with this because there is a functional dependency between these two attributes. When any two couples agree on the value of the city Chennai, they also have to agree on the value of cats. Okay? Similarly, if I have Delhi, although they have to agree on the cats, so it is going to be only. Okay? Right? So there is a functional dependency between city and cats. Now you can see as I captured this relationship like this. Whenever the city appears and one of the cities are tags, next time that the same city appears, the same tag should be captured in the table with the same value. Now you can't have the functional dependency for Chennai, you can't put here as 1200. Then there is no functional dependency to the code. Okay? If you make this FD doesn't exist. These are independent. Chennai and is independent. Now what are you saying? Tax is dependent on what we are now agreeing. That is how the your domain is. Okay. Since your domain is like this, you are seeing whenever two tuples agree on the value of the city as Chennai, they also have to agree on the value of the tax. Okay. Right? So this is how your tuples are going to be. Since the only way the data is going to be in your database. Okay. Similarly, if they agree on 82340, since there is a functional dependency from property number to city to house number to area to price to tax. Once they agree on this number, all other tuples also they should agree upon. You can't have any other values other than what this is having once there is a functional dependency city to house number to area to price. Okay. Now can somebody tell me what will be the problem in this relationship because there is functional dependency between city and tax? What are the likely problems I will face if I capture my data into the system like this? Okay? What can happen? What is one of the problems I am likely to face? Okay? If I store this data like this with this property or relation, with this functional dependency, I store all my data into my system. What would be one of the problems I am likely to get into because of this functional dependency between city and tax? Okay? Can anybody put it into the chat box? If you understand this, more or less you will get into the groove of seeing why it is redundancy. Excellent. I think Jntuk Moocs is saying redundancy. What is redundancy here? What is redundancy? What do you mean by redundancy? Okay. Tax will repeat with city, leading to redundancy. Okay. That's I think you can see everywhere Chennai 800, Delhi 200 got repeated in this. Okay. Now I'll ask one more question. What is the problem with redundancy? Okay. What happens if I have redundancy? This time redundancy captured into my database. What is the problem? What is the problem of redundancy? Original data may not be identified. Which is the A8 column? Can you identify yourself? A8. Which column is this? Okay, the Vasavi engineering column. Good. Okay. So, which is the college I probably visited on last Friday? Is it the same college? Okay. Vijayanagar campus is saying inefficient storage and retrieval. Why is it inefficient storage and retrieval? Can you elaborate? Nothing much is coming back. Okay. Probably what they mean by this is repeated, redundant information. So this stuff unnecessarily is getting repeated in all the tuples. So it's actually a wastage of storage as far as this information is concerned. Okay. That's what probably they're saying. But this is not the real big problem. There is one very big problem with this. Okay. You've still not identified the biggest problem with redundancy, which is a nightmare for any person maintaining this database. Okay? Anybody maintaining this data, it can be a nightmare because of one problem, which is duplication. Redundancy is fine. What is the side effect of this redundancy? People are not still able to identify that. Okay? Inconsistency, that is excellent. Okay. Why is it inconsistent? What happens is they actually seem to be. We even forget how often they have changed these taxes. Okay, right? The papers keep finding out that the tax has changed so many times. Okay, in a month or whatever. So people keep changing these taxes. For example, let us say the city corporation Chennai decides to change this tax. Okay, Chennai decides to increase its tax to, let us say, to update its tax to 12%. Okay, right? Now, you have to find out all the places where Chennai is appearing and update them to 1200. Otherwise, you will be having an update anomaly. Okay? Somewhere you have actually changed it to 1200, somewhere else it still stays 800. You will have an update anomaly. And now finding out all the places, this, and you forgot to change even at one location, then you will have an inconsistency as far as the database is concerned. This is what we call as an update anomaly. Okay? This is what we call. So what are the problems now we are finding? One is duplication. Okay? The information is duplicated. In some places the information got duplicated, leading to inefficiency and all those other problems. More bigger problem is we have got ourselves into what is called update anomaly. Okay? Then you also have a deletion anomaly. For example, you want to delete a record. Okay? Okay. If you have, for example, property record, delete Chennai, and you delete this. Along with this, you also lose the information related to city and tax. That is also lost. Because there is somebody demolished this building. Okay, and this is the only property that is whose record is available in the database. Okay. Now let us say you delete this couple. Okay. Now along with this, the last couple, let us say for Chennai, there is no other couple having Chennai, city and Chennai. Along with this, you will also lose the information that the city, Chennai, and the tax are okay. That's all what is called the rules. You have a duplication problem, an update problem, and anomaly. If you have not taken care of the functional dependency in the relationship properly. Okay. Right? Is that clear now? Any questions? So why these functional dependencies are now important? The functional dependencies are saying how these values are coming together. Now because of that, you get all these difficulties if the functional dependencies are not properly taken care of in this relationship. Okay? Right? Okay? I will give a very simple way to design a database system to start with, but around that, I should warn you, the road ahead is going to become a little steeper. Okay? So keep your concentration. It's an afternoon class, so most important concept, keep your concentration. Okay? To what we are saying. You can ask a number of questions. Okay? Now is the concept of functional dependency clear? Is the concept of, because of functional dependency, what are the kind of problems that you can get into? Is that clear? So this relation is not in shape. Why this relation is not in a good shape? It is not in a good shape because the city and tax functional dependency is not properly taken care of. Okay? In this relationship. What is the best way to avoid all these anomalies? The best way to avoid all these anomalies says if one fact and one phase is that the golden rule that database designers want to follow. A fact and one, you don't want to actually have the same fact stored in multiple locations. Okay? Each piece of information, which is a fact, this is a fact. City and tax is a fact. Chennai has 800. Chennai tax is 800. This is a fact. But now that fact is getting repeated at multiple places. This fact is being stored multiple times in your database. So when this fact changes, for example, the Chennai fact, the fact that Chennai has a tax 100 changes to Chennai having a tax of 1200, then the whole thing will change. You have to go and then update in multiple locations. If you have this concept that a fact is only at one location, okay, a fact is stored in one location, okay, right? We have to go through duplication will be avoided because this fact is only at one location. Update anomaly will be avoided because you just go and change only this at one place. And deletion anomaly will be handled because you know that if you delete this, you will lose the fact, so it will not get deleted unless it is getting out of use. Okay? All these three will get handled if you ensure that in your database system, a fact is stored at only one location and not multiple locations. Okay? Right? How do I essentially ensure a fact at one location in my relation? Okay? How will I handle that? Think of this. This is the crux of the whole design. The rest of the things all will fall because of this into the place for me. Rest of my discussion will be just to get you to thinking this idea, this understanding of how we get this. Okay? Right? Okay? Let me see who is able to think and answer my question. How will you get in a relation a fact at one location only? And one only you want to store it only once. You don't want to store it more than once. Okay? What is the key to actually saying that yes, I will be able to store a fact only once, not more than once? Yeah, okay. You're giving me an answer. Okay. But let me ask you, what will ensure if I create a separate table, what will ensure that this fact will be stored only once in that table? What will ensure if I create a separate table, what is the guarantee that this fact will be stored only once in that table? Distinct constraint. Not exactly. City is a primary key, yes. So, what is the key to understanding now? This fact, okay, whatever is the fact, this has to become a key for the relationship. Why will the key will not get it? Key, as you can see here, once something has a key, and then everything else is determined by the key. All of the attribute values are determined by the key. Okay? Now, understand this property number here. Property number is the key to this relationship. Okay? Now, there's not going to be another tuple with the same value. Because with the same value, if the key repeats, the key is not going to repeat. For the simple reason, if the key repeats, what happens if the key repeats? 8, 2, 3, 4, 0. Let us say this repeats. Since it functionally determines all other attributes, then it has to be channel. Okay? Because this is functionally determined. Number has to be the same. Area has to be the same. Price has to be the same. Tax has to be the same. Since it's exactly the same tuple, since it's a set, two tuples cannot repeat. It will not happen. Which means that if you make something as a key, and the key functionally determines all other attributes, you know that in that relation, that fact will never repeat it. Okay? We are ensuring that this fact will be, if you make every functional dependency, any functional dependency becomes a key, is reflected as a key. Okay? Here, city to tax. If city is not the key in this relationship. As you can see, city is not the key in this relationship. So city is getting repeated. Chanda is getting repeated. Okay? Right? Now, every functional dependency, the left side of the functional dependency, the attribute, becomes key or super key. It's part of the super key. Okay? Either it is a key or super key. Functional dependency, left side of it is either key or a larger key. So it contains the key. Then this fact will not get repeated in the table at all. Okay, the table, you will have this fact will be repeated only once in the table. And that's how you will avoid duplication. You will avoid update anomaly. You will avoid deletion anomaly. Okay, right? So that is a good relation. Your relation to base this property part at one location. Okay, it's a good relation. It avoids all these three properties. It is called a good relation. Now I will just formalize what I said as what is called a normal form. You have to normalize. It's also called normalizing the relationship. Given that a set of FT, I'm giving now a very high level understanding of how you will understand what is a good relationship. Okay? Suddenly this is not a good relation. As you can see here, this is not a good relation because it suffers from all these problems. Because the city versus tax, we have this, it suffers from all these anomalies. This is not a very good relationship. We want to actually, to avoid this, what is the requirement to make your relation into a good relation? What is the requirement? The requirement is that we want to make sure every FP, for example, in this particular case, a relation is a good relationship if there is a functional dependency FD, then the left side of the functional dependency is a super key. In this relationship, every FD, every functional dependency is reflected as the left side of the functional dependency is a super key. Okay? It's part of the key. It contains key plus something more as part of this functional dependency. Okay? If this happens, we say that the relationship satisfies what is called the easy method, which is the voice chord is the original recurrent of the relational model. Voice chord, normal form. Okay, this is a very important concept. Okay? Very simple to understand also. There is not much. If you understand this, what I have told, anytime you will be able to keep this concept without really studying anything more. Okay? The idea is there is a functional dependency between A to B. If this functional dependency doesn't become, okay, Okay. We'll come back to more details of it. Okay. Right? Okay. This is not a super key. It is not, city is not, no, a city does not by itself a key or contains the key. It is only a part of the key. Okay. So this constraint is not satisfied. The minute this constraint is satisfied, it becomes a super key for the relationship. We are guaranteed that this will not be repeated. The fact contained in this FD will not be duplicated, will not have a paid anomaly, will not have a issue. Okay. So what is BCNF? Every functional dependency in the relationship should become the left side of the functional dependency should become a super key. Okay. This is what we call as a voice or normal form. If the relation doesn't satisfy that, it is not a good relation and it will suffer from duplication, update and deletion. If we want to avoid these things, we have to make a relationship that satisfies the voice or normal form so that all the anomalies are avoided and stored only at computation. Okay? Right? Any questions? First, understand, it's very simple. Intuitively, if you understand this, you absolutely will not have any problem. So, you know that this relation is not a good relation. So, you are going to now decompose this relationship. When you decompose this relationship, you look at all the theory behind decomposing this relationship and bringing it to the voice part normal form. Okay? Right? Okay. Any questions on this? Is this clear? I'll give a couple of more examples. Okay. But let me first ask if there are any more questions. First, any questions on this? I straight went into BCNF because intuitively you can easily understand BCNF. Okay? Right? Voice card normal form. Okay, this avoids all kinds of redundancy. When functional dependents are involved, voice card normal form ensures that there are no redundancies. I will intuitively explain why voice card normal form will make sure that none of these anomalies will happen. Because what it translates is, it takes an FD and makes the left side of an FD has to be a super key of the relationship. By it becoming the super key, you know that the key will be unique, key will not get repeated, part will not get repeated, and that's how it eliminates the duplication, update, and deletion anomalies. Okay? Right? Okay? Is that clear? In BCNF, the left side we have only one attribute, no. Okay. The functional dependency is in the set of attributes on the left side, the set of attributes on the left and the right side. Okay. Now, we, for example, okay, a good question. Now let us take formally how we will look at it. Let us take that I have a set of a relation A with a set of attributes A, B, C, D, E, F. Okay, 6 attributes. Okay. Now all these attributes are atomic is part of the original definition itself. That means atomic means they will have only single value, not multiple values. Each attribute will have only one value. So each attribute is atomic. Okay? This is part of the definition here. Okay? We'll come back to this itself becomes the first normal form. First to make a relationship into each attribute is atomic. It will be just having only one value, not a list of values. Okay? Right? Now the functional dependencies are written in terms of A, B can functionally determine D. Okay, or D and E. In which case, ECSF will say AB has to be part of it, AB should be a super key. Okay. Right? So, any functional dependency, anything can be part of the left side. Left side is a set of attributes. Okay? And the right side is another set of attributes. Okay? We'll make one other thing very clear for you. For example, AB functionally determines A. Okay. This is trivially true because if you take a tuple AB, if you take an attribute AB, this will suddenly agree on the value of A. Okay. So what if you take two tuples, they will always agree on the value of A. Right? So AB trivially functionally determines A, the attribute itself, because it will trivially agree on its value. So this is basically called trivial functional dependency. Okay? Trivial FD. This is actually called a trivial FD. So one of the requirements for the BCSF is when you are talking about FD, all non-trivial FD. We are not talking about the trivial functional dependencies. So that's the other constraint. For all non-trivial functional dependencies, the left side of the functional dependency is a super key. Okay? Because trivial functional dependency doesn't add to anything. Okay? You can write a trivial functional dependency. An attribute trivially functionally depends on itself. Okay? Right? So that has to be excluded when we are looking at the void function. Yeah. Okay. Right. So we'll exclude trivial functional dependencies, all non-trivial functional dependencies. For example, you can see here, city and house number functionally determines all other attributes. Okay. And this is also key. So this one satisfies the BCSF requirement that this city and house number functionally determines all other attributes, and city and house number also is key to this relationship. And hence, that functional dependency is satisfying the BCSF. The functional dependency, area determines price, city determines tax. Both those functional dependencies violate the yes. Is there a question there? I'm confused. Okay. Right, the two functional dependencies. See, what are the functional dependencies that are violating now the key this duplication requirement here? Okay. We are not considering the trivial functional dependencies. In fact, when I was in Vasudika College, I was asking girls students who were actually there, did I teach the trivial functional dependency for them? They were looking at and they were seeing each other's faces. I didn't see what is the trivial functional dependency that time. Okay? Now I am actually teaching on the trivial functional dependency. Trivially, property city will determine property number because the attribute is part on the right side, which is also on the left side. The right side is a subset of the left side. It trivially determines the functionally determines other side. Okay. Now let us see which are the functional dependencies that we have written. The first functional dependency that we have written for this is property number determines city, house number, area, time, determines the right. This is also a key. So this also satisfies the BCNF requirement. Also understand, if they satisfy the key requirements, this will make sure that once this is the key, values don't get repeated, and hence duplication, update anomaly, deletion anomaly will not come with respect to these two functional dependencies. These two functional dependencies will not cause these problems because they are key to those problems. The one which says city determines the tax, this FD will cause problems of deletion, duplication, update and deletion anomaly as I explained, because this FD3 is not captured here. This is not key to the relationship, and hence this causes this problem. Similarly, FD4, it says area to price. This also area is not key for this relationship. This also causes this duplication, update and deletion anomalies. Right? So FD, non-trivial FD, these are these are all non-trivial FDs. A trivial FD would have been property number, city determines property number. You can write any number of trivial FDs here. They are not of consequence, they are not important. Right? So these are the two functional dependencies that violate the BCNF requirement that the left side of the functional dependency has to be the key. If the left side is the key, the duplication would have been avoided. As happened in this case, will not get repeated. They will not cause this duplication of data anomalies and deletion. Right? Hope that's that gives the intuitive understanding of what is a good relation versus what is not a good relation. Right? A good relation satisfies the requirement that every FD is not a BCNF because these two FDs are violated. As far as these two FDs are concerned, the BCNF requirement the left side has to be a key is violated. That's why this is not a BCNF. Voice card normal form. If this is the highest normal form you can achieve, for example, if a relation satisfies BCNF and the kind of dependencies that we have in the attributes are only functional dependencies, then all these three will be avoided and you will not have any of the problems you see with this duplication, update, and deletion anomalies. Right? So if there are any questions, I look at other normal forms. I want to first intuitively make you understand. In fact, database wants to have underneath the golden rule for database design. Underneath is one fact at one location. For example, if you are a student and your information is multiple times represented, in the database, right? And at one location, your college writes, Jyoti has a percentage of 89%, and at another location, writes Jyoti has 79%. It is not acceptable for you. This leads to inconsistency. So, for example, at different point of time, your CGPA changes to 90%, but they have updated at one location, but not updated at the other location. This causes inconsistency. You don't want to have in database all these problems. So the golden rule for storing data into the database is one fact at one location. So your relations should be such that we are storing only fact at one location. That's the golden rule for database design. Given that there is a relation, and given that there are set of functional dependencies, you want to actually make sure your relation is in BCNF so that one fact at one location is achieved. Let me ask you a couple of questions. Where are the relational attributes coming from? Where are the relations and attributes are coming from? They are all coming from the domain. Okay. Why nobody is answering? Let me catch hold of. Are there any other questions? Between one college possible. Okay. C11 colleges. I'll go to Vijayanagar campus. See chat. Chitty will do. Are there any questions? Okay. Are there any questions? He's avoiding, not they're not willing to come. None of them are willing to come. Have they followed? Have you understood what I've taught you today, or you've not understood? What is your name, ma? What is your name? What is your name? What is your name?
Prasanna. Prasanna.
Prasanna. Okay.
Prasanna, sir.
Prasanna. Yeah, Prasanna, right?
Prasanna, sir.
Okay. I heard you correctly. Prasanna.
Prasanna.
I am saying, right? What I say? Are you able to hear me?
Sir.
Prasanna, did you understand what I taught today?
Yes, sir.
Okay, let me ask you this question now. Okay? The last question is coming from the college. Let me ask you one question. Okay? Right? How does one key determine given a relation? Given a relation R, determine what's the key for the relation.
Unity determines all the rest.
Correct, but how will you determine some attribute is a key? How will you determine some attribute is a key? Where is it coming from? How do you determine? For example, I give you a student record, roll number and all. So how will you determine now the why is it actually to be low and stage? You need something else. It's all gone. No? Yeah. Now, the interaction is not happening at the level I would like to have. Okay? You see. Okay? Our failure. Okay? Our failure at the age you think. Okay? We don't have that. So let us see if we can look for Vasavi college. The college where I to see if I can go back to them and see if they are trying to, if they are not publishing their video. Then also available detailed video lectures. Additionally, these video lectures are also available. Please look at this very, very carefully. What I want you to do. Okay? Right? I come back and see if I am not able to come back. So I'll come back and see if I can have an additional class on Saturday morning between 10 to 11. Okay? 10 to 11 o'clock. Okay? I hope that's all right from this one. Okay? I'll come back. I would actually, the most important concept, I want to actually stress and ask some questions on it so to make sure that people understand this concept of normalization very thoroughly. Okay? So I'll do one more example. I'm going to do examples on this and show you all the nuances of how to look at this concept of normalization. Okay? Right. So I think, of course, the power has gone, so this is gone off. Okay? I will try to catch the other colleges in the coming days. I think now we will stop here at this point. Okay? And we'll continue with this. Yes, we're going to take some more examples of BCNF percent. Okay? How we can look at BCNF and how we can further look at the normalization carefully in the coming classes. Okay? Okay. And we will stop here. Maybe